Hey, on today's On.NET show, we're going to be talking with the TrackJS project and how they built a real .NET Core, ASP.NET Core application and deployed it to Linux. Check it out. Hey, welcome to another episode of the On.NET show. Today we're going to be talking with Todd Gardner. He's a co-founder of the TrackJS project, and he's going to be telling us about how they're using .NET Core and how they're packaging and deploying their app in .NET Core on Linux. Hey, Todd, thanks for joining us, and how about you introduce yourself, and then we'll get into the topic.
Sounds good, Rich. Thanks so much for having me. So as you said, my name's Todd. I'm the CEO and co-founder of TrackJS, which is a JavaScript error monitoring service that's been around for 7-ish years. Serves a lot of customers there. But earlier this year, we started building something new. We started building a project called Request Metrics, which is going to be a web performance monitoring service. And what we're trying to do with that is build something that's like super easy and super inexpensive to use so that we can empower teams all over the world to build faster web applications without needing, expensive tooling to do it. And as a part of building that, we're trying to use new, more powerful technologies like .NET Core. So we've been using .NET Core as part of this project and recording ourselves as we've been building this over the past few months. We've been recording all of our working sessions and then editing them down and publishing it on YouTube so that the people can watch and see how we're actually building this product that they'll be able to use and see how we're using the technologies, how we're struggling with it, what shortcuts we take, what things we polish and make sure are really good, so that people can see how these real pieces of software get built.
I see. Is that kind of also like part of a marketing strategy to help you build up an audience?
Of course, right?
Yeah,
I mean,
yeah.
when you launch something, you want to have people who are interested in it. And so by producing this thing, we felt like we would be serving multiple goals. We'd be,
totally.
kind of entering something into the educational space, which is something we've long wanted to do. And we felt like we might have a unique proposition of like, we're not going to build a to-do app. We're not going to build a, something fictional that, doesn't have real requirements. We're building something that has a real set of constraints around it. Like, we want to launch by this date. We need to get this out the door. We're not entirely sure if people are going to use it yet. So we have to make compromises along the way. We're not going to build this impenetrable system from, day one. We're like, what do we need to do to get this out the door and see what people want, what people like? And I think those conversations themselves are interesting, that people can see what kind of debates go on when it's not just, it's not a project for the sake of a project.
Yeah, I understand. Working on a real project myself, I understand how to deal with constraints and requirements and deadlines and all those kinds of things. Just one more question before we get into, you show us what you've actually been doing, which is, you clearly have a lot of experience with JavaScript. Why didn't you just use Node.js on the server and call it a day?
Yeah, that's a really good question. So when you're writing something for the web, when you're building a web application that needs to be super interactive and respond to user actions, it's really JavaScript is your only option. You can't there's not a plethora of development languages that you can run and have executed by every browser on the face of the planet. You really have to write it in JavaScript. So you're kind of forced down that path. But when you get to write something on the server, when you're going to get into HTML rendering or data processing or that sort of thing, I have a lot more options. And JavaScript is good at a lot of things, but it's not good at everything. And the static typing that you get, the benefits of link, the benefits of performance. There's so many benefits of writing C#, especially now that I can run it on .NET Core and deploy it on Linux. It's just way more attractive for us to do it in .NET than to write it in Node.
So that sounds like an awesome segue.
Yeah, yeah. So today I wanted to talk a little bit about how we build and deploy our .NET Core application onto our Linux servers, which is something that we covered in one of our earlier video series. So if you want to watch us like bang our head against the wall and figure out how this actually is working, there's a whole like hour, or I think it's probably 35-minute long video about it. But I'm going to show you like how we actually got it working and how the whole thing fits together. All right, so here is a high level of the design that we started with for request metrics and how this fits in. At the top, we have this JavaScript agent that we're going to install into our customers' web applications. So that agent will go out to the end user and it will gather how long did their pages take to load, how long did their APIs take to return, what's the breakdown between DNS time and SSL time, and all that good information. And we're going to funnel that information back to us and capture it with an Nginx server. Nginx is like super fast, like front-end web server that can handle, caching and handling those requests. The two bits of .NET are going to sit just behind there. We're going to have a Linux service that we just call our processor, the request metrics processor. And what that's going to do is it's going to rip through a bunch of those Nginx log files, and we use that to like ingest our data. So all of that data coming in off the agent is being ripped through by this .NET service, and it's being coalesced down together and figure out what we want to do with it and how we want to store it, and we stuff it into a Redis system.
So quick question there. Is the processor batch or is it kind of real time-ish?
It's real-time-ish. So essentially, it's a Linux service that is a executable that's just doing a while loop, just an infinite loop. And so on different timers, it will do different actions. But it's essentially once a minute, it will look for those log files and do a bunch of logic to figure out what we need to pull out of it, how do we coalesce it, and save it into Redis. It has a few other jobs it also does around like cleaning up some of our data, producing alerts based on that data, some other kind of statistical analysis that it does, but it's essentially just a great big loop.
Perfect.
So the other bit is the reporting UI, which is an ASP.NET application that talks to that Redis system and produces all of the reports and login functionalities and settings and all of those other things. That's just going to be running using the built-in like Kestrel web server that comes with .NET, but we front that with Nginx so that we can have a little bit more control about how that fires out to the front or to the actual end user, which I think is a pretty common configuration for .NET on Linux.
Makes sense. So one thing to clarify is that's all fine and makes sense, but there is definitely this one misperception. Early days, we did tell people that Kestrel was not kind of public internet-facing grade, and we did not support it in that way. I think since 2.1, we have supported Kestrel as a public internet-facing server. So that's not a commentary on what you're doing, but it's just a good place to insert that guidance and information.
That's a good point. I actually had not heard that, but there's a bunch of other things that were Nginx that kind of make it necessary in this architecture.
For sure.
Cool. All right. So that's kind of it for this. So let's take a look at how we actually built this. This was, our sketch of, our roadmap of where we were going to go. And then over, the matter of a couple of days or weeks, we've built a lot of this in place. And so I'd like to show you kind of the high notes of how we package and deploy this and get this thing actually running.
Okay, let's do it.
Cool. So here is our solution. So I'm running on a Mac, as you can probably tell, which, by the way, I love that I can do my development without having to like run inside of a VM anymore. It is amazing. It is a game changer. Our project or our solution is fairly simple. We have our web project, We have our processor project, which correspond to our architecture. There's a bunch of like common things about how to talk to Redis and how, our basic business logic works that's in infrastructure. And then we test a bunch of things. Should be fairly similar to a lot of other projects out there. The magic of our publish and deployment from the code side is really all contained in this file, our publish profile. So we have a production publish profile for our web project and our processor project. And there's a couple of bits in this that are what's interesting. The first is, we're targeting Linux x64. This is where we're actually running. We're not running this on Windows. We're running it on Linux. And we get a bunch of benefits with our infrastructure automation by doing that. The second bit that's really been helpful to us is this self-contained property, which, as I understand it, allows us to basically bake in the version of .NET Core that we're using as part of this, as part of our deployment. And so it becomes this was always one of the things that was really fascinating to me about Go, right? Was that if you were building a Go app, you could compile it down and it'd just be an executable, and there was done. You didn't have to install a Java runtime. You didn't have to install the .NET framework. You didn't have to do any of that. It's just here, it's done. It's ready to go. And I think this is amazing. And it really simplified a bunch of our infrastructure deployment by not needing to figure out how to get the right version and how to keep them in sync. I think that's really the magic here. There's nothing else that was really all that strange, other than to simplify, pushing things over the wire. We opted for publish single file, which you probably actually know more about this than I do. But the publish single file basically means it all came down into just a single file. It wasn't dozens of DLLs stripped out over a nested directory structure. We just get a file that's called requestmetrics.web, and it's about 80 megs, but it's ready to go and ready to be deployed.
Yeah, I'll have to, once we're done this, I'll have to show you a link with the 5.0. We have an issue on GitHub that shows you what we're doing in 5.0 for publish single file. So it's better. So I think you'll be happy.
Great. There's a very similar setup in the processor. The processor is a very simple thing. As I said, it just runs as a Linux service, but its publish profile is very, very similar. We publish single file, we publish contained, and it's also going out to Linux. So how this actually works, when we actually run this thing, is for our build and deploy process, we're using TeamCity, and here's all of our different jobs that we're doing with TeamCity. And the request metrics build, which is this guy down here, after it's all said and done, this is what it produces after it's done package everything up. We have this one file here for web, which got a little bit bigger than I last checked, 122 megs. And we have our processor file, which is 110. And so those are our two things. Those are the two main things that need to get out in order for everything else to work and run. And so when we deploy that from here as well. And it's pretty simple what I think we do. Our build steps basically are we just zip up the whole directory using 7-zip. We tar it. It's very old school kind of way of doing things, but it works pretty reliably. We dump it out into the server, and then we extract it. We pull the whole thing apart, dump it into the directory that we expect things to be running in, set their ownership permissions, and then remove the garbage. If it is in order for it to run, in order for it to get everything kickstarted, we have a systemd service running for this thing, just called app.requestmetrics.com, which is its domain that it runs on. And we just wanted to make sure that it stands up and it's running. And so when this whole thing goes, it takes only about a second for this whole thing to work, and can reliably push new versions of code with no downtime or very, almost instantaneous changeovers, because we're just replacing the underlying files and quickly recycling a background service.
That's nice. Yeah, I also think you're kind of a little downplaying your like old school approach, but there's nothing bad with simple and
Yeah, that
understandable.
that is kind of our overall development philosophy. Is there's a lot of new ways of doing things that provide benefits in some circumstances, but the old stuff works really really well. And so sometimes it's just about like copy a file into the right directory and restart the service.
Yeah, it's a little bit like there's been this trend of people going back to static websites.
Yeah.
If your experience can be delivered via a static website, go for it. That's an awesome story.
Yep. The processor has its own deploy. We decided that we wanted the ability to deploy the front end app or the processor separately based on what we were changing and what we were doing. But the deployment of the processor is nearly identical. It's about, we zip up all the contents of the output. We send it up into a known directory structure, and then we extract it out and put it into a processor directory that we're expecting it to run in, and restart an underlying systemd process called requestmetrics.processor. And so this allows us to change the files of our ingestion pipeline in the same sort of way, which I think is really, really powerful for us.
Absolutely. Now, did you have any trouble using .NET Core as a systemd service? Were there any challenges there?
There were problems when we were first getting started. Yeah. So I can show you some things here. So we set up most of our system, or nearly all of the server itself, using Ansible. That's what we use for infrastructure automation. And this is what we use to get all of our services running and make sure that all worked. And we did run into a few challenges with the processor, and which is just native .NET service running as that, and around figuring out the right permission structure to use, which honestly we still have not completely locked down. We ended up punting on this for now and moving on to other things. You can see that right now that service just runs as root, which is not ideal and is on our list of things to fix. But we could, when we first attempted this, and you'll see some of our faffing about trying to get this thing to work in our videos for it. We were trying to get all of our services running as our service account ID. But no matter what we did, we couldn't get the service to run under that ID. The permissions of all the directories that we found, we said everything, and it just would not run. We did find a couple of links to bug tickets in .NET Core about it, but we couldn't quite tell what the status of them were. So we decided to move on for now.
Okay, how about we follow up with that one offline, because I know the people who have played with .NET Core and systemd, so they must know the answer to this.
Sure, that'd be great. That'd be great. Right. So in general, how does this whole thing kind of come together and work? Is through this Nginx, or through this Ansible configuration, which is how we set up our Linux boxes. If you're familiar at all with Ansible, Ansible allows you to set up roles and apply them to a server. And so the servers that run the processor get the rm-processor role, and they basically do these things here. They make sure certain directories are present, like our request metrics directory. They make sure that the service is installed. So we look to see if there's already been a file deployed to this box. We go ahead and we make sure that the service is installed into systemd and running. If not, we make sure that the service is still installed, but it's in a stopped state instead, which allowed us to set up boxes before we've deployed to them or after we've deployed them. It just gave us some flexibility when we were first getting things created.
Makes sense.
And the processor was really, really simple, because it just it's a file running on the box, and we create a service around running it, and off it goes to the races. The website is slightly bigger, if only that we need to make sure that Nginx is running properly. So there's two different roles that are relevant for that. First, the application itself. The application itself is, again, just another Ansible role where we make sure that the directories exist for it. and we create a service account for it. So this part is largely identical. So we create, the directories. There is a process running called requestmetrics.web. We check to see if the file is running on whether or not we should start the service.
Right. So one piece of context, maybe I just missed it, that I didn't hear is, so Ansible, like the reason we're looking at all these files is Ansible is basically your, Linux installation orchestrator, and this information is like the declarative, YAML files that describe what are the outcomes that you want.
Absolutely, that is exactly the context here. So we, prescribe to the ideas of our servers are cattle, not pets. We don't necessarily we never want to log into them directly and make configuration changes. We get all of that stuff working here in Ansible. And what Ansible will let us do is it'll let us take these YAML files that describe certain activities, and it will orchestrate all of them. And we just pointed at all of our production of our dev servers, and we say, hey, make sure all the servers look exactly like this.
Yeah, this is also, this also follows the config as code paradigm.
Exactly. And so we have tons of other stuff in here. We configure everything in here. We configure our we have an Elasticsearch instance that we use for logging. We have our main Redis instance. We have some core Linux things that we do. We have our monitoring that we put in here. But the core of the service is here contained in this RM app role. The other half of this is how we configure Nginx itself. And Nginx itself just needs to know how to pass through to it. And so as part of configuring that, we drop an engine config on the server, which looks like this. If you've ever worked with Nginx, this is kind of how their configuration files look. And it's basically just this block right here. It's saying, hey, we're going to listen on HTTP2 SSL. We're going to listen if you're talking to the request metrics application URL. Here's our certificate information. And we're just going to proxy pass this out to our .NET application, which is configured here. And so this all happens, within the same box, super fast, off and running.
Makes sense. So one thing I haven't seen yet is, so by virtue of publishing as self-contained, you skip having to reason about deploying .NET Core itself.
Yeah.
But .NET Core does have dependencies, like OpenSSL, for example. Where I would expect, actually, I guess I never asked you which OS you're running on, but I'd expect like, some apt-get or yum or, DNF calls depending on which OS distro you're running on.
Yeah, absolutely. So I think we probably just lucked out with not needing to explicitly install any of the .NET Core dependencies. We're running Ubuntu long-term support. I think that's 1404 or 1606. I'm not really sure which one. And then as part of installing all of the other stuff, as part of getting Nginx running, we have all of the dependencies in it, so we don't declare them directly. Although maybe we should. That might be a.
I'd recommend it because it's a little bit of for obvious reasons.
Yeah.
Hopefully it's not 1404 because we don't support that anymore. We do support 1604 and 1804 and 2004.
Okay.
Those are all the LTS ones. It's all the, if you're not familiar, it's all the even years ending in April.
Yeah.
Is how they roll.
Good. So no, we don't have anything that explicitly installs those dependencies. We do install allow OpenSSL, or that's a firewall rule. So no, we must be just relying on it being on the box already.
Yeah, consider that a free code review.
All right, we'll get that fixed. So if we put that all together, the system is running right now, and so if we go,
this is what I was wanting to see next.
If we go to app.requestmetrics.com, we can see this .NET app running, and we can see that it is being fronted by Ubuntu on Nginx. now that we're logged in to request metrics, I'm going to give you just a brief overview of like what we're actually doing with this. This is all very rough still. We're still actively in construction. We're a couple of weeks out before delivering, and we have a lot of CSS and design work left to do. Request metrics is going to allow you to, capture multiple applications. Right now, we have 2 applications that are configured in our account here: the TrackJS www site and the TrackJS doc site. We're dog fooding this on our own properties as we go, although we will be opening this up to beta soon. So if we take a look at our performance of the TrackJS www site, it's going to start producing some of these reports. Now, remember, this is a .NET app. We're rendering most of this on the server side, using a little bit of Preact on the front end to handle some interactivity and chart, logic. But by far, the majority of this is running in .NET Core on those servers. So we're looking at the last 24 hours of data from real users who visited trackjs.com and the performance that they experienced while they were there. We're charting like the average duration of how long the site took to load, and then breaking down what were the slowest pages on your site and what were the busiest pages. We'll automatically do some like URL collapsing so that like if you have a product details page or URLs with unique IDs in them, we'll strip those out. If we look at an individual page, like people who went to trackjs.com, we can get like a lot more detailed. So we're producing these flame charts that show you a breakdown of more detailed experience. So, how many people had an experience of less than 100 milliseconds, so an almost instant page load time. It looks like our average is closer to between 1 and 1.5 seconds. And then how many people maybe have had a really bad experience loading this page? Some people you'll always have a case where somebody's on a really poor connection or a really poor performing device, or maybe the server just took a long time for some other unknown reason. And we'll see, the number of people who took more than 10 seconds for them to load their page. We do the same kind of breakdown for endpoints so that you can see how your APIs perform. So we see like from this page, what were the endpoints that this page calls? How is this page assembled? What does it do?
So an interesting question there is, so it's providing excellent data, and I love the visualizations. But like, since this is actually on your own properties, presumably some of this should turn into an action plan of like, I'm not happy with what these charts are telling me. This isn't good enough. What would be the thing to do?
Right. And so that's the bit that we're working on actively right now, which is our alerting subsystem. And what the alerting subsystem is going to be able to do is it's going to look at the historical trends of your data and notice when things are changing. So if we just visually look at this report, it looks like right around the start of the next day, something changed, right? The number of requests went up, but like there's just the distribution of performance seems to have adjusted. We're building different kinds of alerts in our system so that we can notify property owners or website teams when these sort of changes can occur, so that we're trying to make request metrics a tool that you rarely ever have to log into, but you still depend on because you need the alerts that you get from us. So we'll funnel those out to you that, hey, the performance of your page has degraded in this way, and it's never done that before, so that you can look into those sort of things and respond to them.
Makes sense.
Which, frankly, is the kind of technology that, big enterprise teams have had forever, right? A lot of these things have been available through tools from Microsoft and New Relic and Splunk and, all of the big, application lifestyle management or application lifecycle management vendors. But what we're trying to do is simplify these reports, make them easier for any developer without training to understand what they mean, and deliver it at a price point that will give every team the ability to see these kind of metrics and improve their sites.
Right. So it sounds like pricing is one of the value props that you're planning on bringing to the market.
Right. And we're not entirely sure what exactly that price point is, but it's going to be something like less than $20 a month kind of thing to get, enough coverage that your whole team can see these and react on them, and hopefully improve the performance of your web pages.
Yep. Makes sense. So you've kind of shown us the whole kind of experience from like, your initial choice to how this is your apps are built to how they're deployed with Ansible. And now we actually see the fruits of your labor with this. What else do you want to tell us or show us before you close?
I think I hit all my bullet points.
Okay, then I guess would your kind of statement to the world be, this is what we did and we liked it, and we think this is a fine model, probably among several, but a fine model to use? Is that basically it?
Yeah, so we haven't launched request metrics yet, but so far we are incredibly happy with the .NET Core development experience and deploying to Linux, that experience. It wasn't completely smooth, right? There were still like a couple of hiccups we ran into along the way, but it has no more than I would expect with any development platform. It worked well. Regrets. It works stable. It's never failed in a way that wasn't detectable, right? Because that's always the scary thing, is when things are breaking and you have no idea why, and there's nothing in the logs. Like when things have gone wrong for us, it's always because, oh, we misconfigured this.
Yeah.
Or, there's a memory leak right there. Oh, we got to fix that.
Operator error.
Yeah, it's always been something that like we were able to find and fix and discover, which has been like really refreshing, really easy to work with.
Makes sense. Okay, well, thanks for coming by and showing this. I love seeing a real application being built with the platform, and also you made a series of choices that will resonate a ton with at least some people, and they'll be like, oh, okay, I was thinking about doing it this way. This is validation that actually proves out, and at least made Todd happy. So yeah, thanks for coming by.
Thanks so much for having me.
Okay, this has been another episode of the On.NET Show, and today we've been talking about building and deploying applications for Linux. Thanks for watching.